In this video, we're going to take an overview look at successful testing. We'll start with why. Why do we want to test? Then we'll talk a little bit about the evolution of testing and the history of testing. We'll take a look at some plugins and jars, a little discoverage of how to test in mock, discoverage of what unit test coverage is, and finally some testing tips. So first of all, why do we want to test? One of my coworkers told me once that a unit test is like a code review on your own code, which makes a lot of sense. Sometimes people will say, I don't like to write unit tests because it ends up being so much work. If that's the case, stop and ask yourself, is it that the unit test is a lot of work, or is it that the way the code is written would take a lot of work to unit test it? If the latter is the case, that's an indication that the code was not written in an efficient manner, and that the code might have not been written using proper object-oriented design philosophy or whatever the philosophy is that's used in that programming paradigm. Another reason why we want to test is the importance of App Store ratings and quality, especially in today's marketplace. When I was in college in the mid-90s, I worked in a neighborhood electronics store that sold software. And if a customer bought software on Tuesday and had a bad experience, a different customer on Wednesday would not know about that experience. So to some degree, you could get away with bad quality. Wasn't a good idea, but you could get away with it. Nowadays, if you have bad experience with software, one of the first things you're likely to do is find a public forum, maybe an app store or some other forum like that, and talk about your bad experience with the software. So these days, experience communicates to past, present, and future customers, and so we have to keep an eye on quality. Another item is regression. As we write complex software, we want to make sure that the code that we're writing today isn't negatively impacting something that was already written previously. And so we want to do some regression testing, and we want to make sure that our code has not broken anything. Now, testing is included in one of SonarQube's 7 deadly sins. So one of the 7 deadly sins that talks about code quality is lack of unit test coverage. So we not only have to have the unit tests, but we have to have a way to measure the unit tests. And above all else, it's just a good idea. So what's the timeline? This has been the timeline, I'll just say over my career at least, in testing. And if you think about when I got out of college and when I started writing software as a profession, it was around the mid-90s. And back then, we didn't really have a whole lot of process around test. It was just write the software, try to get it done by this date, push it out. If there's a defect, then we'll figure out how to deal with it at that time. Quality really wasn't up front. So we didn't really have any kind of structured test, and what we did was maybe some kind of manual test where we'd have somebody push on buttons and look for an expected result. After that, when we got to about the turn of the millennia, we started to get into manually writing some unit test cases or some tests that are written in code that tell us what our application should do if our application is working successfully. So it was codified, being written in code, but it was still kind of ad hoc. After that, then we got JUnit, which added a lot of structure and some common language to our tests. With JUnit, then, we could take a look at something called test-driven design. Now, test-driven design means we write the test first instead of last. And at the time, that felt really weird because we started with this process of write the code and then test it. Then we went to this process of test the code and then write it. And the advantage here is many advantages, but one of them is you know when you're done because the test passed. The test will not pass until you're done. The other advantage is this. If you look at the bottom of the slide, I have what we typically call the waterfall approach or the software development lifecycle, what was very common until just after the turn of the millennia. And the idea is we would spend a whole lot of time doing analysis on the software that we want. Then we would get to a technical design. Then we would implement that design. Then we would test. Then we would roll out. Then we would support the rollout software. Now, the trick is, number one, this is the waterfall approach. It has its advantages and disadvantages, and many people are aware of these and talk about them quite a bit. But one massive disadvantage is that this rollout date many times was fixed. And the reality is, in our field, we're not good at estimates. We're not good at making dates. So you had some manager or someone with fiscal responsibility who was looking at this date, and he had all this work that had to happen beforehand. What if this work falls behind the analysis, design, and the implement? What can you cut? The only thing you can cut is the one thing you haven't done yet, which is the test. So a lot of times testing was either rushed, or it was cut entirely, or the testing group just did not get software that was ready to be tested, and so testing tended to get cut. So, by moving the test to the front of this cycle, we assured that we would do the test first and that we would not sacrifice the quality of our testing. So that became really handy. From test-driven design, we went to behavior-driven design. Behavior-driven design is the idea, and something that we've done so far, the idea where we start with requirements in the form of, as a user, I want a certain feature so that I can do something. And anybody can understand the requirements like that. Anybody who speaks the local language can understand those requirements. It's not solely the domain of the technical engineer. It is the domain of the technical engineer, user experience, product management, product ownership. All of the rules are involved in writing a behavior-driven design. Now, from those as a user, I want blank so I can blank, we'll elaborate that into a series of given when then statements, which are essentially examples of that requirement. Now, I talked a little bit about JUnit. That's something that has been used for quite a bit of this history that I'm talking through. And JUnit was initially written for JUnit tests. But one interesting thing is that it really serves as a core framework for all of the testing that we can do, or at least almost all of the testing. It's kind of a common language, this idea of JUnit. Another tool that we can use to help us is the concept of mocks. If we're looking specifically at a unit test, and there's several different tests we can talk about, but specifically a unit test is typically testing exactly one class. And a lot of times we say, well, I can't do that because maybe I'm in a service layer or a business logic layer, and I have a hard dependency on a DAO layer. So I can't test this class in isolation. I have to instantiate these DAOs that my class is dependent on. Well, a mock allows us to not have that dependency and essentially mock something out or stub something out. So it takes away the excuse of, well, I really can't unit test this, and it makes it more unit testable. There are several integrations that we can use in our unit tests. One of them is Cucumber. Cucumber is a tool that takes human-readable Gherkin-style syntax or given when then syntax and maps it to methods. One nice thing about Cucumber is that it can be integrated into a CI/CD or continuous integration, continuous delivery, or continuous deployment pipeline. And that compulsory nature is very important for the success of unit tests. I think back to when I first started teaching programming at the University of Cincinnati, and it used to be that you had to press F9 to compile. That might sound simple, but keep in mind that compiling your code is what gives you red lines. And so sometimes students would be reluctant to compile because they would be afraid they would see their red lines. Well, naturally, red lines are actually really good information because they tell us what's going wrong. So once IDEs started compiling automatically, it would give us that immediate feedback, that immediate red line, and we would be able to fix our syntax errors very quickly. Similar concept with unit tests. If we forget about them, if we don't want them, they're going to atrophy over time and not be worthwhile. But if it's part of our process and they run automatically, then they're more likely to give us timely information and be kept up to date. And a really good way to do this is with a CI/CD pipeline. CI/CD, we can build in things like code coverage, and we can also run unit tests automatically. Here's a sample Git project with CircleCI built in automatically, and you notice that on the commits we have either a checkbox or an X. So this will take me over to a CircleCI dashboard, and if we got the green check mark, it means that everything passed, including the build, the setup, and running the unit test and creating a report out of those unit tests. Now, if we had a red X on the other hand, it indicates that something went wrong, and many times that'll be a unit test, and it will tell us exactly where that test failed. So in this case, we see that I had a test that I intentionally made fail, and sure enough, our pipeline indicated that it failed. Now, the testing triangle, this is something that you'll see fairly frequently because I started this presentation talking about testing in general, but in the last couple slides I was speaking a little bit more towards unit testing. But there again, unit testing, the framework that we use for unit testing a lot is JUnit, and that's something that we see in many different places. But nonetheless, the testing triangle. You see UI at the top, then integration, and then unit. And I want to explain the difference across each of these three types of tests. Because I will use some of the words interchangeably at times or talk about one versus the other. So let's start at the top. A UI test means I reach this endpoint, could be a URL, and I get this expected response. Or maybe I press this button and I get this expected response. Think of what it would take to make that expected response. We're starting at a UI layer. We might have to go from there to a controller, from there to a service layer, from there to a DAO, and then all the way back up. We might need to pull in data from different areas. Okay? But really, if we do a lot of that, it becomes brittle, especially at a UI layer, because UI can change, and many times what we're doing is we're simulating going to a URL and pressing a button. Or if it's a mobile device, we could be simulating opening an app, pressing a button, getting some response. The trick is, what if that button moves on our user interface? Or what if we change the name of the button? Or what if we change what the button does? So UI tests tend to be a little bit brittle. We really don't want UI tests to serve as integration tests. In other words, that full cycle where we're touching everything. We want the UI test to just say, this button should be here with this label. Should be very concise and should be just looking at the user experience. Now underneath this we have integration test. Integration test is where we're actually saying, given this input, I get this output. Now, I talked a little about integration when I was talking about UI, and then I said, well, we really don't want to do integration and UI together. A UI test should just be looking at buttons on the screen or where a text box physically lives. If that's what a UI test is, then what is an integration test? Well, an integration test is where we are saying, I make this call, I expect this result. But now this is interesting. If we shouldn't do that as part of a UI test, how do we do it? Think about Postman, which I used in a previous video where I could act like I'm hitting a URL. That's a way we can do an integration test without actually using a user interface. We are hitting an endpoint, and we're just getting an expected response from that, irrespective of what the user interface looks like. So think about Postman. Think about just hitting this URL, getting this response. Now, think about doing that same thing, but doing it in code without Postman, just hitting an endpoint, getting a response. That's really what an integration test is. No screen needed, just endpoint and response. So you see now we have a better definition of what a UI test is versus an integration test. And that's very important because that line gets blurred quite a bit. Underneath this, we have unit test. Unit test is where we're actually just looking at one individual class and the methods of that class. And we're making sure that a set of inputs gives us a predictable set of outputs. So unit test is looking at one unit of code. Again, we can use things like Mock. Mockito is a good library to make sure that we're only looking at one class. Because if we're looking at one class and its relationship to other classes, then this unit test is no longer unit test, and then that becomes an integration test. So unit test, one class. Integration test, we're looking at an endpoint and its results. User interface test, we're just looking at where the widgets are on a screen. Now, why is it a triangle or a pyramid? When I first saw this, I read it the wrong way. I saw UI on the top and thought, oh, that must be the most important. But that's not the case. The idea here is the amount of relative area should show the amount of tests that you have in your application. In other words, you notice that unit test is the biggest piece of this triangle. What the triangle is telling you is focus most of your time on writing unit tests. Integration tests are important, but not as important as unit tests because integration tests are a little bit more brittle as you have more dependencies. Still important, but they're brittle. UI test, we really want to de-emphasize those and make sure that we're only looking at components on the UI and we're not turning a UI test into an integration test by mistake. So essentially, spend most of our time on unit, a little less on integration, and a little less on UI. Or spend time on UI, a little more on integration, a little more on unit. It's showing relative importance, essentially. So what is a unit test? Test one class in isolation of others. Make it easy to run. Not an integration test, and certainly not a UI test. Mocking. With mocking, what we're doing, this is a really interesting one. Especially if you're a little bit newer to programming. Think about our definition of polymorphism. Polymorphism means variable type tells you what methods you're allowed to call. Object type tells you what happens when you will call those methods. With mocking, what we're doing is we're taking the variable type and we're saying, okay, make an object out of this, but what the methods do, to be determined. Really weird. Really handy, but really weird. So we're saying, okay, I'm just going to make up essentially an object, and then declaratively, I'm going to say what each of those methods should do. What's nice about this is that, remember, this is a dependent object. So we're testing something like a service that has a dependency on DAO. What we're doing is we're just mocking out what the DAO is, and we're kind of hard coding what that DAO should return. Because our point of this unit test example that I'm speaking of is not to test the DAO. It's to test the service, which is dependent on that DAO. So we can isolate or mock out what that DAO does, and we can focus on the service. What's neat about that is that Mockito, which is a mocking tool, also takes account of when methods were called and what parameters were passed to a method. That can be nice because that can be part of our test. We can say, if I run this test, the service layer should have called this method on the DAO layer with these parameters, and it should have called it this many times, or at least this many times, or not this many times. So we can actually use that as a verification step to say our mocked object did call this other object a certain number of times. So that's a look at unit testing, that's a look at successful testing. I'll have several more videos that will look at each of these in more detail. I look forward to seeing you then. Thank you.